Hardware and software requirements. Now, when it comes to the hardware and software requirements, first you need to set up the Arduino IDE software, and you need Arduino board, and this is the main microcontroller that will take our code and use it to create a smart medicine reminder. You'll also need a PC or laptop so that you can write your code, and we have two modules or two versions of the automatic medicine reminder in this course, and the advanced one needs an RTC module, and we will discuss this in a separated lesson. So you need to get RTC module. It's called DS1307, and there's a lot of modules out there. You will also need an LCD display for the advanced product, and you will need buzzer, LED, and push buttons. Now, you will need the Arduino IDE software, which is a free software for writing codes for Arduino board, and you will need a breadboard to connect components together. You will need a 10 kilo ohm potentiometer for LCD contrast controlling, and you will need 10 kilo ohm and 1 kilo ohm resistors. These are mainly the components required to make the simple and the advanced versions of the automatic medicine reminder. In the next lesson, we will discuss the working principle of the simple and the advanced versions of this product, and we will talk in details about how each of them works and which one is best for you. We are going to discuss the simple version of automatic Arduino medicine reminder. Now, we will cover the working principle of this simple version. We wanted to make this as simple as possible, so we didn't use any RTC time module, but instead we used Arduino delay function to achieve our final goal. Now, we all know that each day we have 24 hours. Let me grab a pen. We have 24 hours a day. And in each hour, we have 60 minutes. So 24 hours multiplied by 16 or 60 minutes. Now, to turn this to seconds, we need to multiply this by 60. So we have 24 hours a day. Each hour has 16 minutes, and each minute has 16 seconds, as you can see here. Now, if you want to convert this to milliseconds, you need to multiply this by 1000, since 1 second has 1000 milliseconds. So 24 hours a day multiplied by 60 minutes per hour multiplied by 60 seconds per minute multiplied by 1000 gives us the result in milliseconds. Now, the result for this equation is simple. Let's grab a calculator. Now, 24 hours multiplied by 60 minutes multiplied by 60 seconds multiplied by 1000, and as you can see we have 86,400,000 milliseconds. So this is the result, and this is the delay that we can use if you want to take a pill each, or let's say a pill a day, so every 24 hours. And we'll explain how to do this if you want to take 3 pills every 24 hours or 2 pills every 24 hours. So the code can be adjusted easily. Now, the first thing that we need to know is that we have 86 million milliseconds that we must add to our code delay. Now, after starting the Arduino board, once we load the code that we are going to explain in the coding section, it will wait for 24 hours before buzzing. You can change the delay as your requirement. It won't stop until you press the restart button. We all know that Arduino boards has a restart button, and we will use this button so that anyone can click on it so that we can stop the buzzing and start counting all over again. Now, this means that you have to get to your medicine box in order to stop the alarm. And after you press the button, it will alarm again after 24 hours. Now, to program this, you can easily add a delay function, and we are going to explain this in the coding section of this course. Now, this is the main working principle for the simple version. The advanced version has more components and more coding involved, and it has an RTC module, but the simple version will use the delay function to count the amount of time we need until we buzz. Now, the 86 million millisecond is basically 24 hours a day. Now, if we want to take this pill 3 times a day, it means that we need the device to buzz. We have 24 hours a day, and if we divide this by 3, we have 8 hours. So to do the calculations and to make our Arduino buzz every 8 hours, we need to do the very same thing that we did here, but instead of 24 hours, we will add 8 hours. So 8 hours multiplied by 60 minutes multiplied by 60 seconds and multiplied by 1000 milliseconds. Let's go back to our calculator. 8 multiplied by 60 minutes multiplied by 60 seconds multiplied by 1000. So we have 28 million millisecond, 28,800,000 milliseconds, which is basically the delay that we must add to our code so that Arduino will buzz every 8 hours, and we must press the restart button so that the 8 hours count will start counting again from 0. And we can use the very same principle if we want to take 4 bills a day or 5 bills a day. So it's that easy. It's a very simple device and anyone can do it. The code is a very simple and easy to write code, and we will cover it next. Going to connect our simple version circuit. Now let's start by opening up Freezing software, which is the circuit design and connection software that we are going to use for this project. Now go to the breadboard mode, and in this breadboard mode we need to add the components that we want to use. Now you can use Arduino Uno or Arduino Nano for this project. The choice is yours. You can even use Arduino Micro. As you can see, it's a very small Arduino board. Here we have Arduino Pro Mini, and you can use the famous Arduino Uno if you have it around. Now the same connection will work for all of these boards. They are basically the same boards but with different specifications, but they all have inputs and outputs and power connections. Now first we need an Arduino board, any Arduino board. The next step is we need a resistor, and we also need, let's place this resistor here. We also need a LED and a piezo speaker or buzzer. You can select any of these. So let's say this is the buzzer that we want. We need a LED. Now we also need a battery. So if you are making this device so that you can use it portable, you need to have a power source. And to get the power source, if you couldn't find it here, in this list, you can look for it here. You can write battery and you will get a lot of results. And as you can see, here we have a 9-volt battery. Here we have, as you can see, AA battery, so 3 volts battery. And you can change this to 4.8 volt or 9 volt depending on your needs. So let's add 4.8 volt. We will use 4 batteries because we want to run Arduino at 4 volts. Now, if you look for the current voltage limitations for Arduino, you can easily see that it can operate at a voltage range between 7 and 12 volt. So the best case scenario here is to use a 9-volt battery, one 9-volt battery, and connect it to the positive and negative sides of our Arduino board. Now, once you zoom in, let me show you this. I usually get a rechargeable 9-volt battery for such projects. Now, you need to connect the voltage input from your Arduino board to the VN. So VN will be connected to the positive terminal of the 5 or 9 volts battery, and the ground will be connected to ground here. Now let's change this color to black and this to red. Now once you are done connecting these items together, you can get 5 volts from your Arduino board to the breadboard, and you can connect the ground with the breadboard ground. That's it. Now we need to connect these terminals. As you can see here, we have a LED and a resistor, and we also have a buzzer or a piezo speaker. Now we can connect the ground from the piezo speaker with the Arduino ground, and we can also, let's zoom in. Here we have 2 LED terminals. This one is the cathode. So the anode is connected to the resistor, and the cathode can easily be connected to the ground of the breadboard. Now to turn on the LED and the piezo speaker, we must connect them with the digital input output from our Arduino board. And we can easily do this by simply connecting a wire to digital pin 0, and we can connect a wire from this resistor to the second pin. So let's say that we want to connect them to pins number 3, 2 and 3, and let's change the coloring to gray and yellow. That's it. Now the next step is simply writing the code so that whenever we start running our Arduino, it will start counting, let's say for 8 hours, for 16 hours, or for 24 hours. Then it will turn on the LED and the piezo speaker until we press this reset button to reset the count, so that we will get reminded and we can easily use our board. Now you can also add a switch. So let's say that we want this simple switch. Now you can use this switch here. You can connect this terminal to the switch and the other terminal from this switch to the positive terminal. So if you want to stop the device, if you don't have any medicine to take, you can simply turn this switch on or off to provide power to the Arduino board. Again, the working principle is simple. Once you turn on this switch, Arduino will start counting depending on the code that we are going to write in the next lecture. And if you have chosen the delay to be 8 hours, it will start beeping and will turn on the LED after 8 hours. And if you want to reset the count so that it will start counting for another 8 hours, you just need to press the reset button. And this is the easiest and simplest version of automatic smart medicine reminder. We are going to write a simple code for the simple version of the automatic medicine reminder. Now go to the start menu and open up Arduino. Now, as you can see, this is the Arduino IDE software in which we are going to write our code. Now to increase the font size, simply press on the control button on your keyboard and use your mouse scroll to increase the font size. Now I'm increasing it so that you can easily recognize what I'm writing here. Now the first step is initializing few variables for the pins that we just connected in the circuit design lesson. So let's write constant integer, and we know that we have a red lid, so write red. And let's go back to the circuit design. As you can see, the lid is connected to pin number 3, so let's name it 3. And we also have a buzzer connected to pin number 2. Now buzzer is basically the pin number to which the buzzer is connected. Red is basically the pin number to which the red lid is connected. Now here we need to initialize the lid and buzzer pin as output. So we need to use the pin mode function. So this function will take the name, which is red, and output. And we need to use the same function for the second pin mode. And here we need to write buzz output. That's it for the setup function. Now let's go to the loop function. As you can see, here is the loop function, which we are going to write a code that will keep repeating itself until we hit the reset button. Now the first step will be in this code is beeping for 1 or 2 seconds so that the user will know that the device is starting. So it's basically an indicator. So to produce a beep, we can use the tune function. Now the tune function usually takes 3 parameters, and let's take a quick look at the tune function. So according to the Arduino documentation, the tune function generates a square wave of the specified frequency on a specific pin. A duration can be specified, otherwise the wave continues until a call to no tune is initialized. The pin can be connected to a piezo buzzer, just like in our case, or other speaker to play tunes. Only one tune can be generated at a time. If a tune is already playing on a different pin, the call to tune function will have no effect. If the tune is playing on the same pin, the call will set its frequency. Now, usually you can use the tune function, let's say in any Arduino code, and you can write it in more than one way. As you can see, it can take 2 inputs or 3 inputs. So the first input is the pin number, or the Arduino pin on which to generate the tune. It's basically the pin to which we have connected our piezo speaker. Now the second input is the frequency, which is basically the frequency of the tune in hertz. The allowed data types is basically integers. The third input is the duration. It's the duration of the tune in milliseconds. It's optional, so you can add it or you can ignore it. Now let's go back to our code. Inside the tune function, we need to write few things. First, we need to write the pin number, which is basically the buzz, as we already mentioned. Now, the second piece of information that we mentioned is the frequency. And you can change this. You can choose 1500 to be the frequency of the tune, and you can choose the duration. If you want it to play for 1 second, you can write 100, and 2000 millisecond. 2000 millisecond is basically 2 seconds. Now, this is it. After doing this, what you need to do is initialize a delay for a specific number of hours. Now, I will explain again how you can easily make the calculations for your specific target or for a specific number of hours. And you already mentioned that in the working principle lesson, but we will repeat it again here so that we can, let's say, explain it in more details in the coding section. Now, let's say that we want 8 hours delay between each bill and the next one. Now, if we want 8 hours, we must multiply 8 hours, and we know that each hour has 16 or 60 minutes, and each minute has 60 seconds, and if we want it in milliseconds, we know that each second has 1000 milliseconds. So we need to multiply this using the calculator. So 8 multiplied by 60 multiplied by 60 seconds and multiplied by 1000 milliseconds. So we have 28,800,000 milliseconds. So after that one, we will add a delay function. And inside this delay function, we will enter this number. So let's select it. Let's write it here and let's place it here. Now we must remove these. Now this means that it will delay for 8 hours until the next period to take the medication. Now, if you want 24 hours, you need to do the very same equation, but instead of 8, you will add 24 here and here. Same thing for any other time delay that you want. Now, we will introduce a concept which is basically the go-to statement. The go-to statement is basically a function inside Arduino that tells our code to go to a specific location in our code. So you need to write go to and you need to write a label. So let's call it buzzing and add a semicolon. Now, what is buzzing? Buzzing is basically the buzzing function. So add buzzing, then open a curly parentheses, and we will close this curly parentheses down here. Now, in the middle, we need to write a code to turn on the lid and turn it off and start beeping. Now, to do this, we can simply use the digital write function. So digital write, inside it add the lid name, which is red, and choose high or low. Now this means that the red lid will turn on, and let's add a delay, 200 milliseconds. Now we need to turn off the lid, and let's add a delay of 200 milliseconds too. Now this will turn the lid on, then off with a delay of 200 milliseconds. The next step is start beeping. Now use the tune function, and we already mentioned that it will take 3 inputs. The first input is the buzz or the buzzer pin number, which is pin number 2. The second parameter will be the frequency, and the third parameter will be the delay, 150 or let's make it 300 milliseconds. After that, we need to add a delay. And after adding the delay, let's add 1000 millisecond delay, which is basically 1 second. We need to write a go-to sentence, which is basically a sentence that will cause this to keep repeating itself. So if we wrote go-to buzzing, this means that once the code reaches this line, it will go back to this line. And once it go back to this line, it will start doing all of these lines, and it will turn the lid on, off, then it will beep for around 300 millisecond, then it will wait for 1 second, then it will go to buzzing, which is basically this. So it will keep going in a loop, and the only way to end this internal loop is by using the reset button on your Arduino board. So this is basically a going again to buzzing mode. The code runs until you come near the medicine box and push the reset switch or the reset button that is physically available on your Arduino board. You don't have to connect any external switch. And this is how easy it is to, let's say, create a medicine reminder, a simple medicine reminder. Now, to test this out, let's first save this code. Let's call it simple version. Now, there is more than one way to test this code. Let's first verify it. Okay, we have one curly parentheses that is not necessary here. It was added by mistake. Okay, now done compiling. Now we are ready and our code is ready. What you need to do is simply go to a website that's called Tinkercad. So write Tinkercad here. And Tinkercad is basically a website created by Autodesk for simulation of Arduino boards and Arduino related topics, electronics projects, and things like that. You need to sign in. Now, once you sign in, go to the circuits section, and here you can easily create new circuit. And you can even get Arduino circuits. As you can see here, we have an Arduino circuit with a blink, which is basically a lid. Here we have a tune melody, and okay, I think that we can use this one, the blink, and we can add a buzzer to it. So let's just change this wire to pin number 3, and we need to use a buzzer. So go and write buzz. Here's the buzzer, and we can basically connect the negative to ground and the positive to pin number 2. Now when it comes to coding, you need to go to the code, select text, and click continue. As you can see, this is a code that we need to remove. Go back to our Arduino code, select all, right click, select all, right click, copy, and from here paste. Now let's test this out. Click start simulation. As you can see, the buzzer did buzz for about 2 seconds, and now the code is in this delay and it's executing this delay. And since we are doing simulation, let's comment this line and add a small delay. Let's make it 1000. Okay, now let's start the simulation again. As you can see, for 2 seconds. Now it's turning the LED on and off, and it's buzzing after counting the number of hours. The LED is on and off, then buzz, LED on off, then buzz. That's it. This is how simple this device can be. You can add more functions, but for the sake of simplicity, you can create this device in less than 1 hour and use it to get reminded about the time you want to take the medicine in. And it's a very useful device. I know that we have our mobile phones, but most of the time we forget to put an alarm, or we put an alarm and our battery goes dead. So there is no way that we know exactly the time that we need to take the medicine in. And this device will be the hardware solution to help you solve this problem. In the advanced version, we are going to use more components, and we are going to use the RTC module, which is basically a time module that will give you real data for the date and time, and it will be more accurate than this device. It will have more than one option, and we will add more buttons and LCD display to show things on which we are going to talk about the advanced version of automatic medicine reminder. Now we will explain the working principle of this advanced version. But as you know, the application of smart medicine reminder is very wide and can be used by patients at home, doctors at hospitals, and at many other places. So when it comes to reminding people, there can be many ways to remind them. First, you can show a message to them on a display. You can send them an email notification or an SMS notification to their phone. You can use a mobile app notification system. You can buzz alarm, use Bluetooth, Wi-Fi. You can even get a call to remind you to take your medicine, and a lot of other ways that can be used to remind a patient to take his medicine. We can combine ways depending upon the needs, but we can't add all of these methods in one device because it will take a lot of time to create such device, and adding one of them is more than enough. So to keep things advanced but simple, we are making a simple medicine reminder using Arduino and RTC time module, which reminds to take medicine 1 or 2 or 3 times a day. The time slot can be selected using push buttons. Also, it shows current date and time on LCD display, and we can extend this to become an Internet of Things project in the near future. We can create another updated version of this course, or we can attach a section where a smart medicine reminder that is internet based can easily be done using ESP32 boards. But since this is an Arduino course, we are going to stick with Arduino for now, and we are going to explain the working principle of this advanced version. Now, this is the board that we are going to use. It's called Arduino board. Now this board, Arduino, it will be connected to LCD display, and it will be connected to RTC, which is the time module that we are going to use to take the real data for time and date. Now, the reminder alarm is powered using 5-volt supply. When it first boots up, it shows a welcome message on the LCD display. Now, the LCD screen is set to cycle in 3 screens. The first screen shows a message as stay healthy, get well soon, get well very quick, using this per reminder or whatever messages that you want to display. And the second screen is a help screen which tells the user to press select push button to select any one of the 3 time slots that he wants to use: once a day, twice a day, or 3 times a day. The time slot is changeable in program and can be configured accordingly. Right now, we have fixed this into 3 directions: 8 a.m., 2 p.m., and 8 p.m. You can change this depending on your needs, and we have divided time slots into 3 modes. Mode 1 selects to take medicine once a day at 8 a.m. when the user presses the first push button. Mode 2 will select to take medicine twice a day at 8 a.m. and 8 p.m. when the user presses the second button. While Mode 3 selects to take medicine 3 times a day at 8 a.m., 2 p.m., and 8 p.m. if the user presses the third push button. Now, this is very simple. The 3 buttons will be connected to our Arduino board, and the input data will be sent, and the RTC will send real time and date data. The Arduino code will process the incoming button press with the RTC data and will display data on the LCD display. And we are going to connect a buzzer, and this buzzer will fire an alarm when the time comes for the patient to take his medicine. Now, you can add a snooze feature for 10 minutes if you wish, and you can do a lot of things in the coding part. We are going to explain the coding part in more details next, but for now what you need to know is that this advanced version of the automatic medicine reminder has 3 buttons for 3 modes: once a day, twice a day, and 3 times a day, and it uses the RTC module to take time and date data and provide this data to Arduino to select the time slots on which we want to take the medicine. That are going to connect the circuit for the advanced automatic medicine reminder device. Let's start by opening up Freezing software for circuit design and connection. Go to the breadboard layout mode, and now we need to start adding the necessary components. First, we need to add the buzzer. So drag the piezo speaker and place it here. Let's rotate it by 90 degrees. We need Arduino on a board. So drag a board here, rotate it by 90 degrees and place it here. Now we also need the RTC module. So write RTC. And as you can see, we have more than one. You need to select this one, real-time clock module, which is basically the RTC module that we are going to use. Now, let's start. And before that, we also need an LCD display to show the necessary information. And as you can see, we have more than one module. And this is the most common one, which is basically the 16x2 device. Now let's place it here. Okay. Now we also need some buttons, since we are adding buttons to this schematic. And you can select any of these buttons. Let's drag this one, place one right here, another one right here, another one right here, and another one right here. Okay. Now we need 4 resistors for the buttons. So this is the resistor. Write RES and it will show up here. Simply rotate it by 90 degrees and change the value from here to the common value, which is 10 kilo ohm. Now copy this one and right click and select duplicate or copy and paste. So here's the duplicated one. Place it here. Connect one terminal to ground and the other one to this pin. Duplicate it one more time. Place it down here. Duplicate it again. Place it down here. And the last one is this one. We need to place it here. Okay. Let's move this one. Now we need to make sure that they are connected to this pin. Okay. Now the other pin here must be connected to 5 volts, which is basically in red. Same for here. Same for here. And same for this pin. Now, the next step is connect the 4 buttons to our Arduino Uno board, general input output pins, which are these pins. Now to do this, we can simply connect them to these pins. Let's start from pin number 2, drag the first one and connect it to pin number 2, the second one to pin number 3, the third one to pin number 4, and this one to pin number 5. Now let's connect the module. The 5 volts pin must be connected to 5 volt. And we need to make sure that we are connecting the 5 volts from our Arduino board to our breadboard. Now the ground pin must be connected to ground. So this is it. And the ground from our Arduino must be connected to ground here. Okay, this is the ground. Great. Now we have 2 pins, the SCL and SDA. We need to connect them to our Arduino board. So I will connect the SCL pin. These are for serial communication to A4 and the SDA pin for A5. Okay. Let's make sure that it's visible. And let's change the coloring for these 2 wires to white. Okay, no, not white. Let's make it orange. And this pin, okay, let's move this. And let's change this one, the color dark. Okay. Now we have connected the RTC module. We need to connect the buzzer, and the buzzer can easily be connected. The ground pin with the ground. And pin number 13, let's connect it to the positive terminal of this buzzer. Okay, let's give it a yellow color. Now this is the buzzer, and we have connected the RTC module. We have connected the 4 buttons. Now we need to connect the LCD module. Now to connect the LCD module, you need to know that it has a very specific connection. Now pins number 1, 3, and 5 are usually connected to ground. So you need to drag a wire from here and connect this pin to ground. choose black, and this pin can be connected to this pin number 3, and this pin can also be connected here, which is basically pin number 5. Now if you want to control the contrast, you can connect pin number 3 to a potentiometer, a 10 kilo ohm or 5 kilo ohm potentiometer to control the contrast, but I like to make it simple and I usually connect it to ground because I don't want to control the contrast. Now pin number 2 must be connected to 5 volts, so let's change the color to red, and the next step is connecting the RS and enable pins and the 4 data wires. Now we know for sure that these are the 4 data wires, as you can see, DB4, 5, 6 and 7. So let's connect them. So DB4, which is this one, will be connected to pin number 8. Now DB5 to pin number 9, DB6 to pin number 10, and the last one, which is DB7 to pin number 11. Now we have the RS pin. This is the enable pin. Let's connect it to pin number 6. And we also have the RS pin. Let's connect it to pin number 7. That's it. That's it. Okay, let's change the coloring for these two. Brown and purple. Okay. RS and enable. Now this LCD has a backlight, and as you can see here we have a LED positive pin and a LED negative pin. So the LED negative pin must be connected to ground right here. So choose black, and the LED negative must be connected to 5 volts through a resistor. It's basically a LED. So place it here and connect this LED to 5 volts. That's it. This is our circuit connection for the advanced module, and as you can see we have LCD display, we have Arduino, we have buzzer, we have RTC module, and we have 4 buttons to control. Now let's make a quick summary of this connection. We have connected the buzzer to ground and pin number 13, the negative pin to ground and the positive one to pin number 13. We have connected the RTC module to 5 volts ground, and we have used the SCL and SDA pins for serial communication with the Arduino, and we have connected them to A4 and A5. Now we have connected 4 buttons to pins number 2, 3, 4 and 5, and the other side of the buttons is connected using a resistor to ground, and the other terminal is connected to 5 volts. Now if we looked here, we have the LCD, pins number 1, 3 and 5 are connected to ground, pin number 2 is connected to 5 volts, pin number 4, which is the RS, is connected to pin number 7 on our Arduino to control the LCD, and we have the enable pin, it's connected to pin number 6 to control the LCD, and we have pins DB4 to DB7, 4, 5, 6, 7 connected to pins number 8 to 11. These are the data channels for the LCD, and we have a backlight LED, so we have connected the LED negative to the ground and the LED positive through a 220 ohm resistor to 5 volts to make sure that it won't burn the internal LED. That's it. This is our circuit connection. I will attach it for you so that you can check it out and connect it yourself for the advanced version of the automatic medicine reminder. In this medicine reminder, we are using RTC module, and we are connecting this RTC module to our Arduino board and using I2C communication protocol. And we already have a course about I2C and different communication protocols. You can check it out. Now, you can use any of the RTC modules available in the market. Most of the RTC module has inbuilt 32 kilobyte memory, which can be used to store additional data. RTC modules usually are powered using 3.3 volt or 5 volts from the Arduino. In our case, with this module, the RTC is connected to the 5 volt, but other modules can work with the 3.3 volts, and Arduino provides 3.3 volt, as you can see here, so you can easily connect it to your module. We are using a 16 by 2 LCD display, and we are interfacing this module through the SPI protocol. A buzzer is used so that it will buzz to remind that it's time to take the medicine for the patient. And we are using 4 push buttons. Each has a different feature, and we are going to explain each of them. The first push button is used for reminding to take medicine once a day, and the second is to remind the patient to take his medicine twice a day, and the third push button is used to remind the patient to take his medicine 3 times a day, while the fourth push button is used to stop the buzzer when the user has heard the alert. And this one, or this pin, can be ignored. You can use the Arduino reset pin, which is basically a physical pin that Arduino board provide. This pin. Now let's start talking about how to program it. It's a very easy thing to write a program once you have everything figured out and once you know what you want to do. Now we know the ways to remind taking the pills, and we have 3 ways: once, twice, or 3 times a day. And in this medicine reminder, we are using LCD display, a buzzer that will buzz, and a LED indicator that can be attached or added anywhere we want. It also can have options to select 3 time slots. You can add more buttons if you want more time slots. And when time will reach, it starts alerting the patient by buzzing the buzzer. Then the whole system will look like the following. First, the user will get help instructions on the display. The user will select a time slot using one of the buttons, once a day, twice a day, or 3 times a day. The LCD display will print a confirmation or a message on the LCD display to tell the user the mode that he has selected. The time counting will start, and buzzer and LED will blink or will buzz when the time matches with the user selected slot. The last step is the user stopping the buzzing by hitting the reset button or by hitting the 4th button on our example. We can change the program and the hardware if we want to add more features. And to understand in much simpler way, we have broken down the programming, let's say, steps into a very tiny, easy to follow steps. Now, the first thing that we need to do is include libraries. So let's open up Arduino IDE, create a new sketch. And in this new sketch, the first step is including libraries. So we need to include the liquid crystal or the LCD library. So write liquid, then write crystal, .hex. Now you know that this library is written correctly because the color has changed to orange. The next step is including the RTC library. So write RTC lib.hex, and as you can see, it didn't change the color because we haven't yet added the RTC library. Now we will add it in a minute, but let's add the EEPROM library, and we still need one more library, which is the wire library. Now, the EEPROM library is used to keep the track of user select input if Arduino is not turned on. And when user power on the Arduino, it gets the previous state of push buttons using EEPROM library. The wire.hex library is used since RTC module is using the I2C communication protocol, and this library is basically what we need to initialize the I2C communication. So it's a very important part of our code to check if the RTC module is functioning correctly or not, if it is wired correctly or not, and we will add a specific section to check that in our code, and we will explain it in a minute. Now we need to add the RTC library, so go to the tools, and from there go to manage libraries. As you can see here, we have the library manager. Write RTC, hit enter, and as you can see, we have RTC0 and we have other modules as well. Now, to be more specific on your search, you need to write RTC and write lib for library. And as you can see, here it is, RTC library by Adafruit. Just select install and make sure that you are choosing the glabs RTC library. Click install and install all. That's it. Now we have the RTC library installed, as you can see, installed. Now let's verify the code to make sure that we don't have any errors. Let's save our coding sketch. Okay, now as you can see, here we have an error. And this error is because we haven't added the include word. So write include, hashtag include for each of these. Same for this one, hashtag include, same here, and the same thing here. Now click verify again, and you should see that done compiling without any errors. That's it for the libraries that we are going to use in our coding for this advanced version. Now in the next lesson, we are going to define the variables that we are going to use in this coding section and the necessary pins for our connection, and they must be associated with our circuit, which we are going to continue with the advanced circuit code. Now let's add the code for our LCD display, and to do that we simply need to define few variables here. Let's start by calling these variables by name. We have RS, and we will get the pin number in a minute. We also have an enable pin, D4, D5, we have D6, D7. Now to get these pins number, we need to go back to our circuit design. Now this is our circuit design, and as you can see here, we have these pins and each of them is connected to a separated pin. Now D4 is connected to pin number 8, so 8, 9, 10 and 11 here are for data pins. So let's go back, 8, 9, 10 and 11. Now the RS and enable pins are basically these two pins, this one and this one. Now this is the enable pin and it's connected using this thread wire. Let's see here to pin number 6. So let's go back to our code. This one's to pin number 6 and this one to pin number 7. So now we have the LCD pins. We need to call the LCD function, and to do that we need to use the liquid crystal library. And let's create a new object and call it LCD. It will take these values RS, enable, D4, D5, D6 and D7. This will be the input to our LCD module, and if you miss any of these numbers or if you did write it wrong, your LCD won't function properly. Now this is regarding the LCD configuration bits. The next step will be using main LCD functions, and to do that let's go inside the setup, and before calling the LCD let's call the serial module to debug our code, and let's call it at this baud rate 9600. This is basically to start serial for debugging. After that we need to call our LCD, and to do that we need to write lcd.begin. It will take two inputs, which is the number of rows and columns, and we have a 16 by 2 LCD display. Then we need to clear the LCD using the clear function, and we need to set the cursor to the beginning of the first line. So we need to use the set cursor function. 0, 0 means first column, first row. Now we need to print something. Let's print medicine reminder, or let's call it medicine reminder. Now the next step is going to the second line, lcd.set cursor, and go to 0, 1. First column on the second line. Now let's print something else. Edu and team. Now let's add a delay, and let's make it 1000 milliseconds. Now this will initialize the LCD module, clear the LCD, move the cursor, print something on the first line, move the cursor to the second line, and print something on the second line. Then it will wait for a few seconds. After that we have to define the push buttons. So we will use the pin mode function, and inside it we need to enter the pin number, and we need to go back here. We have 4 pins connected to pins number 2, 3, 4, and 5. So we will have to write 2 input. Now pin mode 3 as input and pin mode 4 as input. The last one is pin mode 5 as input. Now that's it. We need to set, let's see, we also have a buzzer here, and the buzzer is connected to pin number 13, so we need to set it as output. So pin mode 13 output. Now let's add a delay, 100 milliseconds. That's it. This is how to start the LCD and how to set the buttons and buzzer as input and output inside the setup function. Now we added this line to start the serial communication debugging and to make sure that everything we are doing is correct, and we will get results on the serial monitor by clicking here. In the next lesson, we will start getting involved in the RTC module to check if it is connected or not, and we will create some functions that will handle most of the requests for us. But that's it for this lesson. We are going to start dealing with the RTC module. The first step is going up here and write RTC underscore DS 3231. Now this number can be changed depending on the type of RTC that you are using, and in our case it's DS3231, and we need to create an object and call it RTC from this library. Now this will be an indicator of the RTC IC, which will give us real-time data for date and time. Now the next step is making sure that this RTC module is connected, and to do that we need to go inside the void setup here. Now below this serial.begin line, we need to ask using an if statement if RTC.begin. Now we need to add this sign before it, and this line means if the RTC module is not yet connected, do the following. And what we need to do here at this point is type something in the serial monitor, serial.print, and here we will notify the user that we couldn't find RTC module, which means that there is a problem with connecting this module, and it will keep doing that until we have connection. Now the other if statement will check if the RTC module is powered or not. Now if RTC was powered, then it did lost power. There is a function for that, and in this case we also need to notify the user that RTC lost its power. Now, if RTC module lost its power, you have to set the time again. That's why most RTC modules comes with a 3-volt battery to make sure that the time that you did set will remain there. and most of the time RTC module won't lose power unless you unhook the battery, the 3-volt backup battery from that module. Now, if you want to set the time and date manually, you can simply do that by writing rtc.adjust, and inside this function you can write date, time, and inside it you can write the date and time. So we are in 2020 August, so 8:13, and the time is 6:01:00. This is basically the manual way for setting the time. Now, after doing this, we need to make sure that we don't have any errors. Let's verify our code. As you can see, done compiling, we don't have any errors. Now, the next step is defining the LCD, writing things on our LCD display, defining the input and output pins. Now, the next step will be dealing with EEPROM, and we are dealing with EEPROM because we want to save certain values for the push buttons, the 4 push buttons that we used in case of power loss. And to do that, we have to store the high or low button state on an EEPROM memory location. Let's say that we have stored this, and we will do that in a minute. We need to read the data from our EEPROM location to know exactly which button was pressed. Now, to read this data, we need to initialize a variable. Let's call it value button, and let's use EEPROM.read function, and it will take the address as input. Now the address is basically the EEPROM address, and the value button is basically a variable that will store the current button that was pressed or the previously pressed button in case of power loss. So we have to configure these two variables, and to do that we need to go up here before this area. Now here we can start by initializing the variable. So let's call it value. Okay, we called it here value button and address. Let's call it value button and give it an initial value of 0, and let's also initialize the address and make it equal 0. That's it. Now the next step is using if or switch statement to identify the button that was pressed using the EEPROM memory location. And to do that, we can simply use switch. Inside it, we can add the value button, and here we can add different cases. So if the value was 1, we need to print something, serial.print ln, and here we will write set for once a day. Now the next step is creating variables for the push button state, and first we need to initialize these variables here. Let's call it this variable area. Now what we need to do is create an integer let's call it push button 1 state, and let's give it an initial value of 0. We need 3 push button 2 state and push button 3 state. And to make things more clear, we need another variable for the push value state, and let's give it an initial state of 0. Let's copy the name, go back to the switch statement, and make it equal 1, because the user did press 1. And let's do the same for 2 and 3. This one is 0, the user didn't press it, and this one is 0. Now the last one is the push value. We need to paste it here. The push value equals 1, which means that we have pressed the first push button. Now we need to do the same thing. Let's add a break here. We need to do the same thing for the second case, so we will copy this and we will paste it here. Change this to 2, 2, and here we have pressed the second button, so this will be 0, 1, 0. This will be twice a day. And we will do the very same thing for the third button. This will be 3, 3. And this will be 0. Here we have 1, 3 times a day. Now that's it. Let's verify to make sure that everything is written correctly. As you can see, done compiling, we don't have any errors. Now that's it for the button checking using the EEPROM memory address. In the next lesson, we are going to create 3 different functions for each of these buttons, and we are going to call these functions inside the loop function. I know that this is a very long code, but we are learning a lot here. I hope that you understand everything that was explained in this lesson. If you have any question regarding anything, I'm here to help you. And I will do a quick summary again for what we have done here. We created a few variables and we went inside our setup to check if RTC is connected correctly. If not, it will print this on the serial monitor. Now, if RTC lost power, we will tell the user that RTC lost power and you have to set the time again. And we have used a manual way to set the date and time, as you can see, using RTC.adjust. After that, we called the EEPROM address in which we have, or we are going to save the button pressed number. And once you call the read function, it will return the value stored inside this address, and it will store it inside the value button variable. And we used a switch statement to check the value button to see if it is the first button, the second, or the third. Now we use different variables, as you can see, push button 1 state, 2, 3. In case if it is 1, it's once a day. The first one is 1, and the push value is 1. 2, it's twice a day. The second push button is 1, and the push value is 2. Now if it's 3 times a day, 3, 3, and 0, 0, 1, push button 3 state is 1, and 3 times a day. In the next lecture, we are going to create functions for the push buttons. Now, go outside the void loop and write void push button 1. Now, inside this function, what we are going to do is basically ask if. Now, inside the if statement, we will ask if the push 1 state, which is basically this one, okay, push button 1 state, equal 1. Now in this case, if push button 1 state equal 1, it means that we have pressed the first push button. And in that case, we need to do the following. We need to set the push button state for buttons 1, 2, and 3 to 0. Same here. And same here. After that, we need to write the EEPROM address that we just mentioned in the previous lesson. And what we are going to write is basically 1 to the address that we have defined. Now, after writing to this address, we can write on the serial monitor and inside the serial monitor we can write push button 1 was pressed or is pressed. Okay, now we can also write the address to which we have written. So we can write here EEPROM.read from the address. After that, we can save the state of the push button 1 by simply using the push button value or push value variable. We can write 1. Now we can do LCD coding. We can clear the LCD. Then we can set the cursor to the beginning of the first line. So it will be 0, 0. And we can print something to tell the user that the first push button was pressed and the once a day mode was chosen. Now we can write print remind set to. Now we can move the cursor to the second line, set cursor, and here we can write 0, 1 to move it to the second line, and then lcd.print we can write once a day. Then we can wait for 2 seconds. Then we can write lcd.clear to clear our LCD. Now this function is for the first button. What we need to do is verify our code to make sure that we don't have any errors. Then we need to duplicate this function for the second and the third buttons. Now I have copied this. Let's paste it here and let's paste it once more. Now we have 3 functions. The first one is this one, push button 1. Now this is the second one, which is push button 2. And inside it, we can change these. Push buttons 2 state equal 1. We need to keep these to 0, 0, 0. The address, we will write 2 to this address. And here we will write push button 2 as pressed. And we will write the push value 2 here. Then we will change this to twice a day. Now here we need to use 3 and push button 3 state equal 1, and inside the address we will write 3, and here we will write 3 to the push value. We will do the same here, change this to twice a day. That's it. these are the three main functions for the push buttons. Now, we need to call these functions at the beginning of our loop or void loop. Here, we will call the first function. Then we will call the second function and the third function. Now we call the three of these three functions because each of them has, as you can see here, an if statement that will check if this button was pressed or not. So only one of these three will be executed. Now, to read the status of each of these push buttons, we need to store what we are reading here inside these three variables. So we need to copy this, and inside the void loop, we will write these three lines: push button 1, push button 2, push button 3 state, and we will use the equal sign. And to simply read the button state, we will use the digital read function, and inside it we will enter the push button pin number. And as we already mentioned, the button number is basically 2, 3, 4, and 5. We need to use 2, 3, and 4. So let's go back here, 2, and we will write the same line for 3 and 4. That's it. These are for reading. Button state. And then once the void loop returns back here, it will have new values for these three buttons, and they will be applied inside this if statement. Now, if we press the first button, it will equal 1 and will execute this function. If we press the second button, which is push button 2 state, we will execute this function. And if we have pressed the push button 3 state, it will execute the third function. That's it for the. Now, what if we want to stop the buzzing and we want to turn off the buzzer? We will create a specific function for that, and we will use one of these functions as a reference. We will copy this last function and we will paste it here to save time. Now, inside this function, we will call it stop buzzer. Now, what we'll do is we will ask if the fourth push button is pressed or not. So let's go back here to the main void loop, and let's add a new line for the fourth push button, which is number 5, and let's call it buzzer button state. Now let's go back to our function, and inside this function we will ask if the buzzer button state equals 1, then this will mean that the push pressed. Let's remove the EEPROM line, and let's remove this line, this line. Okay, now going back here. Now let's remove this serial line too. Remove this one. Now, here we need to say time to take listen. And here, okay, we can say time to take medicine here. Okay. Now LCD clear, everything is good. Now this one, we need to change it with something else. And let's first go up here and create a new variable. Let's call it buzzer button state. or let's call it flag. Now, if the buzzer button or the stop button was pressed, we need to set the flag to 1 to make sure that we know that this button was pressed to stop the buzzer. Now, that's it for the stop buzzer button. Let's verify the code to make sure that we don't have any errors. Okay, now we have this one. If buzzer button state equal 1 was not declared, so we need to declare it up here. Int buzzer button state equals 0. Verify. Which are going to start coding the RTC time IC or module and get things ready to set the time and the reminding time. Now, to get things started, first we need to set the reminding time, and to do that we need to go back here, up here, and let's start defining few variables. First, we need to set the reminder change time, and we have 3 reminders. First, we have a buzzer at 8 a.m. and HH mean hour. Now, it will be at 8 a.m. and we need to do the same for the minute and the second, so mm and ss. Now this will be 00 and this will be 00. Now we need to do the same for the second reminder. Now the second buzzer will be buzzer. The second buzzer will be at 2 p.m. and we have to set the time in the 24-hour format mode, so it will be 14, and we need to do the same for the seconds and the minutes. So mm and ss. Now the same will be done for the buzzer at 8 p.m. and int buzzer at 8 p.m. minutes, int buzzer at 8 p.m. seconds. Now equal. Now this will be 20. This will be 00. This will be 00. Again, 20 and 24 hours mode means 8 p.m. Now, we also need to define a few variables for the now or the current minute, hour, and seconds. So int now minute, and now second. These are to show the current minutes, hours, and seconds. Okay, we can use this as a small. Now, the next step. Now we need to define a function before the void setup function to display the time. So let's call it time display. And inside this function, we will write, or we will use the date time library. And let's create an object and call it now rtc.now. Now we need to clear the LCD, then set the cursor. After that, we need to print something to indicate what we are showing, which is time. So we will show time, then we will move the cursor 1, 2, 3, 4, and we can add double quotation 5. So we'll move the cursor 6 points, 0 or 6 on the very same line, which is 0. After that, we need to print the hour. So to print it, we need to write now, which is the variable that we just defined, hour, which will equal now dot hour, and will be displayed in decimal. We will do the very same thing for the rest. So we will print this sign, double points. Then we will print the minutes. So we will use this line, lcd.print, and instead of hour, we'll write minutes, m, now.minute, now.minutes, or minute, which is the function that will grab the current minute and display it on our LCD display. Then we will print these two double points, and we need to print the seconds. Now seconds, let's make sure that it's written correctly, and here we'll write seconds. That's it. Now we need to move to the second line using the set cursor. So 0, 1, and we need to print the date. So we will copy this line, and instead of time we'll write date. After that, we will print the date using this line, now.day, and we will add a sign after the day, which is the slash sign. Then we will print now.month, and the last thing that we will print is the year. So copy this, paste it here, now.year. That's it. This is what you need to do to display the time on your LCD display. Now let's verify to make sure that we don't have any errors. Done compiling. Now the next step will be defining functions for the 3 reminding times, which is at 8 a.m., at 2 p.m. and at 8 p.m. And to do that, we need to create a function for each of these 3 reminding times. To create the function, we need to go to the end of our code, write void at 8 a.m. Now inside at 8 a.m. we need to create the date time now, rtc.now, to get the current date and time. Now we'll ask, using 3 if statements, if the hour and minute and second match the buzz time for the hour, minute and second for the reminder time that we have set. And to do that, we simply need to use 3 if statements. This is the first one, and inside it, let me show you this in a more reasonable way. Now inside it, we will ask using another if statement, and inside it, we will use another if statement. Now the first if statement will check if the now.hour, if the current hour is above or equal the buzz or the buzzer, which is basically this variable. Let's go up here, buzzer 8 a.m. hour, since we are creating this 8 a.m. So if it equals the buzzer 8 a.m. hour, then we will check if the now. Okay, now before doing that, we need to make sure that we convert this to integer, and to do that, we need to use the int function and put these inside two parentheses. The next step will be copying this line, pasting it here and here. Now we need to check for minute and for seconds. Here we need to change this to, this will be hour, this will be minute, and this will be second. And inside here we will use the start buzzing function. Okay, here we have a stop buzz function, and in the next lesson we'll create another function which is called start buzzer, and I will define it now, and we can create it in our next lesson so that we don't have any compiling errors. Now if you did check or verified your code, okay, this one above or equal, above or equal, above or equal. That's it, done compiling, we don't have any errors. Now, if the current hour matches the buzzer 8 a.m. hour, and the current minute matches the buzzer 8 a.m. minute, and the current second matches the buzzer 8 a.m. second, it will start buzzing. Now we will do the same. We will copy this very same method, and we will paste it here. And we will paste it one more time here because we have 3 reminding times. Now we'll do the very same thing. We will change each of these. Here it will be at 2 p.m. and instead of 8 a.m. we will write 2 p.m. 2 p.m. and 2 p.m. Now we'll do the same here at 8 p.m. So we'll change this to p.m., p.m., and p.m. These are basically the core of our code. If the current time matches the reminding time, which is 8 p.m., it will start buzzing. Otherwise, it won't buzz. Okay. Now, this function will start buzzing at 8 p.m. This one will start buzzing at 2 p.m. This one will start buzzing at 8 a.m. depending on the mode that you have selected. And we are going to select the mode inside the void loop, but we will leave that to one of the coming lessons. But for now, let's verify the code. Okay, we have few issues. Okay, the PM, I think that we made it small. The variable up there. So PM, and let's check if we have any other spelling error. Okay, 8 p.m. and PM. Okay, verify again. Done compiling. Now in the next lesson, we will create the start buzzer function, and we will adjust the void loop to handle these 3 functions at 8 a.m., at 2 p.m. and at 8 p.m. Thanks for watching this lesson. We are going to code the start buzzer function. Now, to code this function, we need to make sure that first we check if the stop buzzer function was called or not. And we can simply do that by checking the flag, which is buzzer button flag. Let's copy this flag and let's go down here. Now let's check if the buzzer button flag equals 0. This means that the stop buzzer is not pressed, and we can write the code inside this if statement. First, we need to write on the serial monitor start buzzer. Now the next step will be turning on the buzzer. And to turn on the buzzer, we can simply turn on the LED associated with this buzzer, which is pin number 13. And to do that, we can use the digital write function, and inside it we can write 13, then high. This will turn on the buzzer and it will start buzzing depending on the code state. We will go back here to add some lines, but let's go back to the void loop function, which is the most important function, and we need to add a few things inside this function. Okay, going back, this is the void loop function. Now, after calling the push button 1, push button 3, 2 and 3 functions, we need to check. We will use if statement to check. Now inside the if statement, we will ask if the push value, which is basically the push button state indicator, which is this one, push value. If it equals 1, it means that we have pressed the first button. If it equals 2, it means that we have pressed the second button. And if it equals 3, it means that we have pressed the third button. And we did explain that in one of the previous lessons. So we will check if the push value equals 1. Now, if it does equal 1, we need to call at 8 a.m. function, because choosing 1 means that we are choosing once a day. Now, else if it equals 2, then we will have to call at 8 a.m. and at 2 p.m. And else if it equals 3, in that case, we will have to call at 8 a.m., at 2 p.m. and at 8 p.m. Now, let's verify the code. Then I will explain what we have done here. Now, if the push value equals 1, it means that we have chosen once a day. And it will go and call this function at 8 a.m. And when we go to this function, which is called at 8 a.m., it will check if the hour, minute, and second match with current hour, minute, and second. As you can see, we have values here for these three variables to indicate 8 a.m. It will start the buzzer, and once it calls this function start buzzer, it will go to the start buzzer function and it will check if the stop buzzer is not checked. Then it will start the buzzer and will start buzzing. As you can see, pin number 13 will turn on the buzzer. Now, to turn off this pin, which is pin number 13, we have to stop the buzzer, and to do that, what we need to do is basically call the stop buzzer function. This function will check if we have pressed this button, it will clear the LCD and it will set the flag to 1, which is the buzzer button flag. And if we went back to this function, which is start buzzer, if the flag is 1, it won't execute these two lines, so the buzzer will stop. Same thing for other times, like 2 p.m. and 8 p.m. And this is basically how this code works. Now, the stop buzzer function can be modified, and we can add more conditions inside this function to make sure that it will react accordingly. But we need to call the stop buzzer function in the void loop inside it. So if we went back here, we need to call stop buzzer function. Let's make sure that we have the name right. It's a very long code, so it's really hard to keep track of all of these names. So stop buzzer. Okay, stop buzzer. We need to call it inside the void loop to make sure that it will update the flag value. And that's it. Doing this will help us get reminded once a day, twice a day, or 3 times a day, depending on what we have chosen. Now you can add an LCD line to tell the user to select one of the buttons. And as you can see here, inside the void setup, we have added the medicine remind and our team name. Now we can add additional lines. We can clear the LCD. We can copy these lines to clear the LCD. And here we can say press 1, 2, or 3. And we can label the buttons to select mode. And we can display it for 3 seconds so that he can read it. So he can press either 1, 2, or 3 to select the modes. And you can circulate these sentences. You can say press 1 for once a day, then you can clear the LCD display, then you can say press 2 for twice a day, and you can clear it again. I can do it, so let's comment these lines. I will give you more than one way to do this. We can clear the LCD, set the cursor, so press 1 for once a day. Okay. Press button 1 once a day. Now we can wait for 1 second, let's say 1.5 seconds, then we can clear the LCD. After that, we can display these lines, press 2 twice a day, and then we can clear the LCD and add the very same line, press 3 or twice a day, and we can copy them, press stop buzz. That's it. This is how you can tell the user what he should do to select the mode that he wants to use this device with. That's it for this lesson. Thanks for watching. If you have any question regarding any part of this code, you can copy the part that you have problem with, paste it in the Q&A board, or send us a message. I'll be more than happy to help you.